Hello and welcome to your algebra recording for week 10, or we are also in the week of March 14th. So a happy early St. Patrick's Day to everybody. I wanted to share the picture of some buds that are starting to pop up on some of the trees out there around town. So headed into another warm week. Just a reminder that you do need to have a math notebook out. You do need to take notes. These notes will help you when you go to do the assignments this week. One of your assignments this week is the unit test, covering all the sessions that we did in descriptive data, descriptive statistics. And the warm-up question is going to help get you ready for that unit assessment. So in this warm-up, we've got a data table, and the points from the data were plotted. So there's 4 data points, right? 1, 2, 3, 4. And then 2 lines of best fit were drawn in. And we want to figure out which line, the red one or the blue line, is a better fit for the data. And we're going to do that by finding the sum of the squared residuals for each the red line and the blue line. So go ahead and click pause and work on the warm-up problem in your math notebook, and then when you're ready to share your work with mine, go ahead and click play. Alrighty, so this is a great review of residuals. So what a residual is the distance between our data points and the line. So it's the distance, vertical distance. So from, let's say we've got this point 3,5, the residual is going to be the distance between that point and the red line, and also that same point and the blue line, because we're going to find the residuals for each of ours. So the residuals is the distance between each point and, where's 1, 2, there's my 4th line, and a point that actually falls on the line of best fit. So that's what a residual is. So that is a residual. It's the distance, the vertical distance between the plotted data point and then the distance between that point and then the point that actually falls on your line of best fit. That is your residual. So since I've got all the residuals highlighted for the red line, let's go ahead and find the residuals for the red line. So let's start with this point right here, 2, 2. And then the point that falls on the line is at 2, 3. So we see between the vertical distance of 2, 2 and 2, 3. So we want to focus on the vertical. There's a 1 unit. So I'm going to put 1 for my residual. And then I'm going to square it, and then I'm going to add it because we're finding the sum of the squared residuals for the red line. So then I'm going to look at my next point. My next point is at 3, 5, and then the point where it falls on the actual red line looks like it's 1 unit away as well. So I'm going to do 1 squared. And then I'm going to do the next from my next point. The point was at 4, 6, and then the actual point on my line of best fit looks like it's at like 4, 5. So it's 1 unit apart again. So I'm going to do 1 squared because we square the residuals. And then my last point is at 5, 2, and let's count 1, 2, 3. It's 4 units away from the red line. So then I'm going to square that. So we need to find the sum of all of our squared residuals. So 1 squared is 1, 1 squared is 1, 1 squared is 1, 4 squared is 16. So 16 plus 3 is 19. Oops, I meant to put equals, not another plus. 19. And then we're going to do the same thing. We're going to find the sum of the squared residuals for the blue line. So I'm going to erase everything I've got up here. We're going to do the same thing with the blue line. If you need more time, go ahead and click pause before I erase everything. All right, so we're going to do the same thing. Maybe let's change our highlighter to green since we're doing. So now we're going to find the distance between each point in the blue line. So starting with that point 42, it's 1 unit away vertically from the blue line. So we'll start with that 1 squared. Then we've got our next point and the blue line. We've got 1, 2, 3 units away. So 3 squared. And then my next point and the vertical distance away from the blue line is 1, 2, 3 again. So another 3 squared, and then that last point, it looks like it is 2 units away from the blue line. So 2 squared. Add all, or square those. 1 squared is 1, 3 squared is 9, 3 squared is 9, 2 squared is 4. Add all those up, so 9 plus 1 is 10. And then we've got 13, so 23. And so we find the sum of squared residuals to help us determine which lines are better fits for our data. So the closer the sum of the squared residuals is to 0, the better the line of fit is. So the closer the sum is to 0, the better the fit. So based on that, which line would be the better fit? Would it be the red line or the blue line? Well, 19 is smaller than 23, so that means that the blue line is going to be a better fit because it's closer, because the sum of the squared residuals is closer to 0, and that's why. All right, so moving on to the next slide. If you need more time here, go ahead and click pause. All right, so this week, I think I mentioned this already, we're going to complete a unit review in Edgenuity, and then we're going to complete the test in Edgenuity on the descriptive data unit. Then we're going to move into a new unit that's all about linear applications, and this week we're only going to complete 1 session in the new unit, and that's going to be on recognizing patterns, which is what we are about to embark on right now. So patterns can come in the form of sequences, and sequences are just a set of numbers, and we refer to each number in the sequence as terms, and the numbers are arranged in a particular order that makes it a sequence. So there's 2 types of sequences that we're going to focus on this week. The first one is a geometric sequence that we have already studied, so this is something we should be familiar with, and an arithmetic sequence, which is something that's going to be new to us. So let's take a look at the 2 types of sequences. So let's start with what we're familiar with, geometric sequences. So a geometric sequence occurs when you increase or decrease by a certain multiplicative number. So let's look at this geometric sequence right here. So how do we get from 2 to 6? So remember, we need to focus on multiplying when we're talking about geometric sequences. So what number times 2 gives us 6? It's 3. What times 6 gives us 18? We're multiplying by 3 again. To go from 18 to 54, we would multiply by 3. 54 to 62, you got it, we would multiply by 3. So what's important in a geometric sequence is that from each term to the next one, we're multiplying it by the same number every time. So the number has to be the same that we multiply it times every time. And again, we're multiplying, and that's what makes it a geometric sequence. So that number that we multiply by the previous number term to get to the next term, that's what we call the common ratio. So when we're talking about a geometric sequence, the common ratio is the number that we multiply the previous term to get to the next term. And the way that we can find In this case, it would be 3. The common ratio would be 3. And a really quick way to find the common ratio is just to take one number and multiply it by the previous term. So choose any number and multiply it by the previous term, and that's going to give you your common ratio. So you choose a number and you, oh, did I say multiply? I meant to say divide. I think I was saying multiply, but I meant to say divide. So choose a number, divide it by the previous term. So choose any number and divide it by the previous term. And that will give you the number then that you're actually multiplying each term by to get to the next one. But to figure out that multiplicative identity, we're going to take a number and divide it by the previous term. And that's a quick way to figure out our common ratio. All right, where arithmetic sequences are a little bit different. It's all about adding or subtracting to get to one term to the next. So if we go from 3 to 11, we're obviously getting larger, so we know that we're adding. So what do we add to 3 to get to 11? Well, 8 times 3 gives us 11. Let's see if we have that same pattern. What can we add to 11 to get to 19? We would add 8. What about from 19 to 27? We would add 8. So same type of pattern here, that we have to have the same number that we're adding to each time. We can't have +2, +6, +9. It's got to be the same number. And that makes it an arithmetic sequence. We can also subtract. We can be getting numbers that are decreasing. But when we talk about how we get from one term to the next term, here we call it a common difference. It's called the common difference instead of the common ratio. And in this case, our common difference happened to be a +8. And a quick way you can determine is just to look to see, are you increasing and then, or are you decreasing? And then check to see what you add to the number to get from the previous number to get to the next number in the sequence, or the next term. And just a heads up, we always call, so if we've got like a sequence, this arithmetic sequence, we call it, here's our first term, we typically call that A1, our second term is A2, this is A3, but this is our first term, our second term, our third term, our fourth term, our fifth term. So we always start with the first term and just increase one at a time. So I'm going to go on to the next slide, so if you need more time, go ahead and click pause. All right, so if we're given a sequence, we can do some investigating to determine if it's geometric or if it's an arithmetic sequence. By determining if we're multiplying our number by a certain ratio, or if we're adding or subtracting our numbers by a difference. So let's look at the first sequence. So from 1/2 to 1 to 2 to 4 to 8, do we see a pattern? Are we increasing or are we decreasing? Let's ask ourselves that first. So here, 1/2 to 1 to 2 to 4 to 8, so I see we're increasing. And are we increasing at a steady amount, like the same amount each time? So 1 to 2, it's going up by 1, and then from 2 to 4, we're increasing by 2. From 4 to 8, we're increasing by 4. So that would not be an arithmetic sequence, because we're not increasing by the same amount every time. So let's look and see, how do we multiply? How do we go from 1 to 2? What do we multiply 1 by to get 2? Well, 1 times 2 gives me 2. What about going from 2 to 4? What do I multiply times 2 to get to 4? I would multiply 2 times 2 to get to 4. And then I can keep checking. 4 to 8, it's times 2. And we can go back and do that to the 1 here, 1/2. I just kind of went to the whole numbers, and we're looking at those because to me it's easier to see the patterns when we're talking about whole numbers. But we can go back and see that 1/2 times 2 does give us 1. So because we are increasing by multiplying our previous number times 2, and we keep doing that, the previous number times 2. So this would be an example of a geometric sequence, because we're multiplying each previous term by the same amount. What about number 2? What about number 2? So are we increasing or decreasing? 14, 12, 10, 8, 6. So we're definitely decreasing. So now let's see, are we decreasing by the same amount each time? So when we go from 14 to 12, we decrease by 2. When we go from 12 to 10, we decrease by 2. When we go from 10 to 8, we're decreasing by 2, and 8 to 6 also by 2. So since we're decreasing by the same amount every time, what type of sequence would this be? It would be an arithmetic sequence. Oops, arithmetic sequence. And that, our common difference here, would be -2. Where up here, our common ratio would have been what? It would have been 2. So the common ratio would have been equal to 2, +2. Where down here it was a -2 because we're decreasing. All right, I'm going to go to the next slide. So if you need more time, go ahead and click pause. All right, so you're also going to learn a lot about recursive formulas this week in Edgenuity. So a recursive formula is just the idea that each term in a sequence is defined based on the previous term. And we saw that as we looked through the geometric and arithmetic sequences, that each term in the sequence was based on the previous term, whether we multiplied the previous term by a certain ratio, common ratio, or we added or subtracted a number to get to the next term. So we've got some special notation when we deal with recursive formulas that I want us to focus on that you're going to see this week in Edgenuity. So here, first question says is if f of 1 equals 10. So what does that mean? When f of 1 equals 10, what am I getting at there? What it's saying is this is the first term. This is our first term. I guess I should just... So f of 1 equals 10 lets us know that that's the first term in our sequence. It's the first term. So 10 is the first term in our sequence, is what that's letting us know. Then we see here it says f of n plus 1. So this means our next term, the next term in our sequence. And f of n here is going to represent the previous term. So this is going to represent the previous term. And then we're going to read this again. And what that plus 5 means is that we're adding 5 to the previous term. So let's read that again. It says, the question says, if f of 1 equals 10 and f of n plus 1 equals f of n plus 5, what is f of 3? And f of 3 is they're looking for the third term. What is the third term in the sequence? So again, f of 1 represents our first term. Then we're given a formula that says, okay, so the next term, f of n plus 1, that's representing when you take your first term and add 1 to it, so it's the second term, the next term. So the next term is going to be when you take the previous term, the first term, and add 5 to it. And then the question is asking, what is the third term? So in order to find that, we need to find the first 3 terms. So again, I know that the first term is 10, because f of 1 equals 10. So to find the second term, I'm going to take it says take the previous term, or first term, which was 10, and add 5 to it. And I get 15. So the second term, the fancy way of saying the second term is f of 2. That really represents the second term. And then to find the third term, which remember the fancy way of saying that is f of 3. That represents our third term. We're going to take the previous number, the term, which was 15, and now we're going to add 5 to 15. And I get 20. So here I can see that my first term was 10, my second term was 15, and my third term was 20. So the formula was just telling us we take a term and add 5 to it. Take a term and add 5 to it. So we could really we can find our fourth term by adding 5 to the previous term. So that is what all that notation is that f of 1 is our first term, and then where it says f of n plus 1, that's saying to find the next term, we're going to take our f of n, our previous term, which happened to be 10, and add 5 to it. Then to find our second term, our previous term was 15. We added 5 to 10 to get 15, and then to find our third term, we took our previous term, which was 15, and we added 5 to it to get 20. So what kind of sequence was that? What kind of sequence is this if we have 10, 15, 20, 25? Is it geometric or arithmetic? Since we're increasing, and up here it tells us by plus 5 every time, so looking at this formula and seeing that plus 5, that's a giveaway that this would be an arithmetic sequence because we're adding to the previous number each time, so it would be arithmetic sequence. All right, so look at number 2. So number 2, now we know a little bit more. It says if f of 1 equals 160, so we know our first term is 160. So if we're starting to kind of write out our sequence, that's our first term, 160. And then it says to find the next term, we're going to take 2 and multiply it times the previous term, f of n. F of n, remember, represents the previous term. And we want to find the f of 4, which is telling us we want to find the fourth term. That's what we're trying to figure out here, the fourth term. So let's do it. Let's do our math. So to find, I'm going to change font just so we don't get confused with the old stuff. So the first term, so we know we're trying to find the fourth term. I'm going to get rid of that. So to find the second term, which we just say f of 2, that's our second term, is equal to, it says 2 times the previous term. Well, f of 1, remember, was 160. So I'm going to take 2 times 160, and that gives me 320. So now I know 160 times 2 is 320. So my next term, or my second term, will be 320. Then to find the third term, that's just, we can say that by saying f of 3. We're going to take 2 times the previous term, and now our previous term is 320. So 320 times 2, I know, is 640. So the next, my third term is 640. Then to find my fourth term, which is what we were asked for, which is the same as f of 4, we're going to take 2 times my previous term, which was 640. 640 times 2, we're getting bigger, is 1,280. So we're done. We found the fourth term. But my last question is this an arithmetic or geometric sequence in number 2? So looking at the formula up here where it told us that to find each number in our term in our sequence, we're going to take 2 times the previous number, 2 times the previous number. So because we're multiplying times the previous term, we're going to have a common ratio, right? Because we're multiplying, which our common ratio is equal to 2, which means we've got a geometric sequence. All right, and you'll get practice like that this week. I'm going to go on to the next slide, so if you do want to click pause to take some notes, go ahead and click pause now. And we are going to stop here. So in the sequence below, I have a sequence 4, 2, 0, -2, -4. I want you to tell me if that sequence is a geometric sequence or an arithmetic sequence. And then you also need to tell me how you knew or why you chose geometric or arithmetic to get full credit. So directions to complete the key phrase assignment are below in case you need that reminder. Otherwise, have a wonderful rest of your week. And as always, let me know if you have any questions as you're completing this week's assignments.